Hello everyone, welcome back to this channel. Let's continue intermediate machine learning. As of now, we have completed introduction and missing values. Today we are going to understand categorical variables. Categorical variables means non-numeric. So, in this tutorial, we will learn what a categorical variable is along with three approaches for handling this type of data. Categorical variables means different kinds of category. A numerical variable means number. If you don't know, I have a blog there I have written about types of data. You can just give it a single read. This is a categorical variable, whether roti or rice. Numerical means how many rotis you are asking for or how much rice you are asking for, that is numerical variables. Okay, and numerical variables can be divided into two types: continuous, discrete. Categorical variables can be divided into two types: nominal, ordinal. Nominal means when there is no particular order, but ordinal means when you have some order. It's like you have high school diploma or bachelor's degree or master's degree. These are distinct ordered categories. Okay, you just can give it a single read. Anyway, this topic is about categorical variables. So, introduction. A categorical variable takes only a limited number of values. Consider a survey that asks how often you eat breakfast and provide four options: never, rarely, most days, every day. So, you have to choose any one among all these options. Okay. So, these are limited. It's not like numerical, you don't have infinite values. So, in this case, the data is categorical. If people responded to a survey what types of car, whether it is Honda, Toyota, Ford, there are different categories. So these variables are called categorical variables. Okay. Now, the problem is that if you try to plug these variables into machine learning models without pre-processing, your model will not work. So first you have to pre-process them, because machine learning model doesn't understand string. Okay, it only understands numerical values. So you have to convert these strings into numerical values. Now how? That is what we are going to learn today. Okay. So there are three approaches. First one is drop categorical variables. That is the simplest approach. We learned this category while handling missing data also. You just simply drop the variable. You think, okay, there is a categorical variable. Okay, remove that column. Okay, but that is not useful when you need that particular column, right? Next approach is ordinal encoding. Ordinal encoding assigns each unique value to a different integer. It's like, see, never represented as 0, rarely 1, most days 2, and every day 3. So you have given a order 0, 1, 2, 3, and every value is represented by different number. This is known as ordinal encoding. Okay. So whenever you again get most days, what will be the value? 2. Okay. So you are pre-processing your column which contained string before, which contained categorical values, now converted to numerical variables. Okay, now it is containing numerical values. Now you can give this column to your machine learning model. Okay, clear? Now there is an indisputable ranking to categories. Not all categorical variables have a clear ordering. That's what I have told you here also. Some values do not have any particular order. It's like roti and rice. You cannot give them any order. So they are under nominal categories. But when you are following an order, then you are actually using ordinal variables. Okay. Fine. For tree-based models, you can expect ordinal encoding to work well with ordinal variables. Now the next approach is one-hot encoding. One-hot encoding is going to be used most of the times. So it creates new columns indicating the presence or absence of each possible value in original data. Now see how it works. You have three types of color: red, yellow, green. Okay. Now in the first what you have to do? You have to create column names with unique values. Red 1 value, yellow second value, green 3. So red, yellow, green. Okay. So you have created 3 columns. The number of unique categories. Okay. Fine. Now what you are doing? First, you are giving red as 1. So it is 1. Now yellow 0, green 0. So when machine learning gets the first row, it understands that the value is red. Okay, because this is 1. Then second one, see, this is 1. But in case of yellow, you have to make yellow as 1, all others as 0. In case of green, you have to make green as 1, all others as 0. Okay. What if there is one more category, let's say blue, then you have to create one more column. Let me show you. Then you have to create red, yellow, green and blue. So in case of red, you will give 1, all others 0. In case of yellow, yellow will be 1, all others will be 0. In case of green, so it will be 1, others will be 0. In case of blue, all will be 0 and it will be 1. Okay, simple thing. this one will be 1. Okay, next if it one comes yellow, then again one, it will be 1, others will be 0, right? This is known as one-hot encoding. In the original dataset, color is a categorical variables with 3 different categories. So one-hot encoding contains one column for each possible value and one row for each row in the original dataset. Exactly. Whenever the original value was red, we put 1 in the red column. When it was yellow, we put 1 in the yellow column. That's what I have said. Now in contrast to ordinal encoding, one-hot encoding does not assume an ordering of these categories. You can understand that, you can understand that there is no particular order, right? But in case of ordinal, you have an order, right? So one hot encoding does not assume an ordering of the categories. So you can expect this approach to work if there is no clear ordering. Okay, and this is the intrinsic ranking of nominal variables. Okay, one hot encoding generally does not perform well if the categorical variables takes on a large number of values. That you can understand. Let's think that there are so many values: red, yellow, green, blue, violet, and many others. Then what will happen? You have to create columns for each of them. So how many columns will be generated? So many. So it never works very well with large number of categories. Okay. You generally won't use it for variables more than 15 different values. Now, the previous tutorial we used Melbourne housing price dataset, so we are going to work with this only. See, same thing, I am not going to repeat. Price you have to calculate, Melbourne housing prices dataset, and missing value columns are dropped. Okay, and now this is the thing right now we have. Okay, now we obtain a list of all the categorical variables in the training data. Okay, so we can check this by using dtype. You know, dtype data type, it will help you to check which types of data is existing in the column. So if you write extend.dtypes equal to object, then keep it in object underscore column. So it will give you a list of all the categorical variables. Okay, if it is object, keep it in object underscore columns. So now you can print the categorical variables: type, method, region name. These are categorical variables. So you have to first pre-process these categorical variables before you give it to machine learning algorithms. Okay. Now the score dataset function, it compares 3 approaches to dealing with categorical variables. It will calculate MAE, the same we used before also. See, random forest, fitting, predicting, error calculation. Okay. Now what is the first approach? Score from approach 1, we drop the object columns with select dtypes method. Okay, so this method will be used to select the to drop the object columns. Now see, extend dot select underscore dtypes exclude object. Drop x valid, select underscore dtypes exclude object. You are doing this for training, you are doing this for validation. Okay, now you are calling this function. So you are passing extend, drop x valid, and y train y valid, and it will give you a score. Okay, so this is the score. First one. Second approach, ordinal encoding. Here you have to import ordinal encoder. Now you are creating copies so that it doesn't get lost. Okay, now first you have to create an object. As usual, you have to create an object. Using that object, you will call first fit transform, then fit transform for training objects, and then transform for validation. Okay, you are not fitting for validation. Okay, extend object columns when these columns are holding string values, categorical values, all these 3 columns. Okay, because you have kept them in object underscore columns, so you are here passing those columns and you are transforming them. Okay, now you are checking the score. See, earlier it was 17, now it is 16. So we randomly assign each unique value to a different integer. This is a common approach that is simpler than providing custom levels. However, we can expect an additional boost if we provide better informed levels. Let's see, one-hot encoding. For using one-hot encoder, you have to import one-hot encoder. This one. Okay, you have to create an object first, then you can apply one-hot encoding. There are a number of parameters that can be used. Okay, handle unknown, this is a parameter. This is to avoid errors when the validation data contains classes that are not represented in the training data. Let's say in validation data, you may get something new, okay, that is not in the training data. So what it will show you? It will show you an error. It will tell you that I have not seen this in training, during training, so how can I give you an output? So to handle this kind of error, simply error handling, or I can say exception handling, you are using handle underscore unknown equal to ignore. Okay, Now setting sparse equal to false means that sometimes it returns sparse matrix. Sparse matrix means it has too many zeros in that particular matrix. So to handle those sparse matrix, you have to write sparse equal to false. Okay, so that you can ensure that encoded columns are returned as a numpy array. If you don't give this, sometimes it shows an error because it faces problem with the sparse matrix. Okay, now to use encoder, we supply only the categorical columns and we want to be one-hot encoded. Fine, for instance, to encode this training data, object columns, list of columns holding object data, and so X10 contains all of the categorical data in the training set. Okay, so see, as usual, you have to create an object. They are giving two parameters that handle unknown values and handle sparse matrix. Now you are using this feed transform and transform on validation. Okay, so you have applied one hot encoding on categorical columns. Now one hot encoding removed index, so you have to put the index back. So extend dot index equals to this new dot index. Okay, so index are regenerated. Now you have to remove categorical columns and you will replace this with one hot encoding. So you are doing extend dot drop object columns. Remove all those values, all those columns where it is containing a string, right? Same for X validation. You have to do this for all of them. Now what we have to do? We have to add this applied one hot encoded columns. Okay. So for that pt.concat, this is where you have stored the one hot applied encoded columns and x is equal to 1 means you will answer in the comment section. And same it is for validation. Okay. Concat method will help you to concatenate. Now ensure all the columns have string data type. So for that you are using as type. You know about as type function, it helps you to convert the data type of any particular column. So you are converting it into string. Okay. If it is not in string, it will be converted. You are just ensuring. Okay. Now you are printing what is the value. So you are calling score data set, it will be trained, it will be predicted, it will calculate the accuracy. Okay. Now, which one is the best? In this case, dropping the categorical column performed worst since it had highest MA score. As for the other two, since the returned MA scores are so close, it doesn't appear to be any meaningful benefit. So in general, one-hot encoding will typically perform best and dropping the categorical columns typically performs worse. Okay, it in general, but machine learning is all about trial and error. Okay, so it is not like that it will always give you the best result. It depends on the types of data and types of algorithm and what is your purpose. Okay, so the world is filled with categorical data, you have to be very much effective. So let's do the exercise now. First you have to do the setup. Okay, now you are will work with this data set. So let's run this. Same, you are importing pandas, you are importing trend test split, and you are removing the columns with missing values. Price you have to, the setup is complete, not yet. Price you have to calculate. To keep things simple, we will drop columns with missing values, break of validation from training data. So all these things are as usual, and here you can see the training data set. Okay, just wait for the setup is complete, and this is also done. So let me run this one. Okay, see, you have to calculate the price. So you can see so many categorical columns. Let's see. Okay, notice that dataset contains both. You will need to encode categorical data before training a model. To compare different models, same score dataset. We will just run this. Same thing, you are just training, you are just predicting, you are calculating error. Now, drop columns with categorical data. You will get started with most straightforward approach. Use the code cell below to pre-process the data in extend and X validation to remove columns with categorical data. The first approach. See, I will copy, but I will suggest you to write it by yourself. Okay, where is that? This one. Okay, you have to drop this. So drop extend, drop X valid. Let me copy both of them. Okay. Run the next code cell to get MAE. See what is the error. 17. So before jumping into ordinal encoding, we will investigate the dataset. We will look into condition 2 column. Okay, let's see. This code cell prints the unique entries in both the training and the validation dataset. Unique values in condition 2 column in training data, norm, POSA, FEDR, POSN, artery, all these have some meanings, norm, Okay, so you know what is unique? It will give you the unique categories. Okay, training column, the column names, and in the validation column, the column names are different. This column is not present in training dataset. This column is not present in training dataset. Okay, so there may be a problem. Let's see. Ordinal encoding. If you now write code to feed an ordinal encoder to the training data and then use it to transform both the data, then you will get an error. Why is that so? You can understand that there are problems with column names. Okay, so what happened? You are training these columns, you are giving them a number, unique number. But in case of validation, this one didn't get any number during training. Okay, so it will throw an error. It will ask who am I and what is my number, and there will be no answer. So there will be a problem and it will give you an error. Let's read this. Fitting an ordinal encoder to a column in the training data creates a corresponding integer valued label for each unique value that appears in the training data. You will get a value for this one, for this one, for this one, for all of them. But this one is not present here, so it is not getting any value, right? So in that case, the validation data contains value that don't also appear in the training data, then it will throw an error because you have not assigned any value. Okay. Now, there is a common problem. You will face this problem. For instance, you can write a custom ordinal encoder to deal with new categories. But it is better that you drop the problematic columns and you keep the good level columns. Okay. First, see. Here, what you are doing, you are first taking the categorical columns that we have done before also. You are just selecting all those columns where the data type is object and you are keeping them in object columns. Okay, so these columns are categorical columns. Now you have to separate good columns, bad columns. So how? First one, you are creating a for loop on these particular columns, on those categorical columns, and you are checking that whether the validation data set is a subset of training data set. That means all those columns which are present in the validation data set are also present in the training data set. Okay, so you are checking whether this set is also a subset of this one. Okay, this is a set data type in Python. I hope you know. Each subset is used to check whether all these values in X validation is also present in all the in the training columns. Okay, in the training data set. Okay, so once you get them, you are storing them into good level columns. Okay, so you have all the columns, you have got the good level columns. Now if you subtract them, then what will be remained? The bad level column, simply. So you are creating a set of this one, you are creating a set of this one, you are just subtracting and you are keeping the result into a list. Okay, so these are the good level columns, these are the bad level columns. Perfect. Now use the next code cell to ordinal encode the data in extend and xvalid. Set the preprocessed data frames into okay. So first drop categorical columns that will not be encoded. So you are dropping the extend dot drop bad level columns you have just selected. So you are just dropping them. Okay, access equal to 1, you column wise you are dropping. Now you have to apply ordinal encoder. Again I am going to copy. See, first you have to create an object. You have to do fit transform on training and transform on validation. Simple concept. Okay, send this. See, found unknown categories because these categories were not present in column 9 during transform. Okay, because here we are applying this ordinal encoding on the object columns, that is this one. So what you have to do? We have to do this on good level columns, right? So just copy this and paste it here. Good level columns, good level columns. Okay, now let's run this. Okay, run the next code cell to find the MAE. 1700. So far you have tried two approaches to dealing with categorical variables and you have seen that encoding categorical data yields better results than removing columns. Now we are going to use one-hot encoding. Okay, first get the number of unique entries in each column. Okay. So we are taking lambda anonymous function, we are taking the training data set, we are calculating how many unique columns on categorical variables, then we are creating a list of that. Then we are grouping the columns with respective unique numbers and creating a dictionary. After that we are just sorting item wise. Okay, ascending order. Fine. Now, investigating cardinality. The output above shows for each column with categorical data the number of unique values in the column. For instance, the street column in the training data has two unique values, GRV1 and pave, corresponding to a gravel road and paved road. Okay, for street column you have two unique entries. Now we refer to the number of unique entries of a categorical variable as the cardinality of the categorical variable. So street column has 2 cardinality. Cell type column has 9 cardinality. Okay, the types, total number of types is the cardinality. Now use the output above to answer the questions below. Okay, so fill in the line below how many categorical variables are in the training data have cardinality greater than 10. So greater than 10. 25, 16, 15. So exterior first, exterior second and neighborhood. 3. Fill in the line below how many columns are needed to one hot encode the neighborhood variable in the training dataset. 25. I told you while doing the red, yellow, green. So if you have red, yellow, green, there will be 3 columns. If you have red, yellow, green, blue, you will have 4 columns. Okay. So number of unique types of values. So you have to use 25 categorical columns. Fine. Now for large dataset with many rows, one hot encoding can greatly expand that we have discussed. For this reason, we typically will only one hot encode columns with relatively low cardinality. The high cardinality columns can be either dropped or you use ordinal encoding. Okay, so first you will check that unique types. Now if you see that these are huge like exterior second, neighborhood, exterior first, so you may avoid them for one hot encoding. You can do the ordinal encoding for them. Okay, because for one hot encoding it will be huge, the number of columns will be so many. Okay, that will be a problem. Now for this reason, we typically do this. Okay. Now then high cardinality columns can be either dropped or we use ordinal encoding. As an example, consider a data set with 10,000 rows and containing one categorical column with 100 unique entries. Okay. So if the column is replaced with the corresponding one hot encoding, how many entries are added to the data set? If this column is replaced with the corresponding one hot encoding, one categorical column has 100 unique entries. For 10,000 rows, if there is 100 unique entries, then it will be 10,000 into 100. Okay. Now, how many entries are added to the data set by replacing the column with ordinal encoding? Nothing, because for ordinal encoding, you are not adding any extra column. Okay. Next, you will experiment with one-hot encoding, but instead of encoding all the categorical variables, you will create a one-hot encoding for columns with cardinality less than 10. Okay. So, run the next code cell below to set low cardinality columns to a Python list containing the columns that will be one hot encoded. Okay, so high cardinality columns will be dropped from the dataset. Okay, so what you are doing here, you are separating them. You are first calculating what is the cardinality. That means how many unique values each column has. Okay, now if it has more than 10 columns, then you will simply remove them. If it has less than 10 columns, then you will do the ordinal encoding. Okay, that is the concept. So how we are doing? First we are calculating the low cardinality columns for only those columns which has number of unique values less than 10. Okay, you are taking all those columns. And what are the high cardinality columns? You can just simply subtract. So subtract from all the categorical columns minus the low cardinality columns. So it will be kept in high cardinality columns. Okay, so see these three, because these are greater than 10. Okay, now if you want to take up to 15, so you can write less than 16, then there will be two columns, right? Exterior second and neighborhood. Clear? Now you are applying one hot encoding, so you have to process extend x valid and keep it in there. Okay, so use as many lines of code as you need. Okay, what you have to do, full list of categorical columns that can be found in Python list object columns. You should only one hot encode the categorical columns and all other columns should be dropped from the dataset. Okay, so let me first copy, then we will do the edit. This is ordinal encoding and we will do this for this one. So let me take the whole thing, then I will edit. Just copy and paste. See, this is fine. Ordinary hot encoder, you are just creating an object. Now you are transforming not only object columns, but you are doing this on low cardinality columns. So you have to copy this and you have to paste it here, right? For this also. Okay, now it has removed index, so you have to put the index back. You have to remove the categorical columns. You are adding one hot encoded columns, two numerical features, and you are ensuring all of them has. Okay, I think it is fine. Let me run this. ME from approach 3 incorrect. Which extent should have 155 columns. Okay, sorry, here I have made it 16 for you, so that is why. So I have to do this 10. Now let me run this. Let me run this again. Now okay. Now run the next code cell to see the MAE. Generate text prediction. See, this is the error now, and submit your results. Okay. Okay, so we have done this one, categorical variables. In our next class we will study how to use pipelines. Okay, bye, happy learning.